All right, so good afternoon. Happy New Year, everybody. Hope you're doing well. So welcome to water quality. I think we're still missing one person, but I guess we'll just get started here anyway. And so today we're going to talk about the course outline, and we're going to actually do the first topic as well. Course outline shouldn't take very long, and we'll get right into things. So let's talk about the course and what to expect this semester. I'm going to turn my video off and I'll give you guys a chance to talk here in a moment. So let me just talk about the course outline. So that's me. I think I know everybody here because I had you last semester in the 108 lab. Right now we're online, I guess, and our labs are going to be in person. So I'll talk about labs in a bit. I'm hoping that will change. Online is just not quite as good as the real in-person thing, is it? But for now, we're going to be meeting on Zoom for lectures until labs start, and then I'll see you in person. I'm working at home kind of probably 3 to 4 days a week. So in terms of office hours, if I'm there and you're on campus and you want to drop in, feel free. I'm just not sure if I'm going to be there until things resume to in-person. So if you do need to meet me, you can try to drop in, or you can, probably the best way to do it is to send me an email and we can set up an appointment and we can either meet in person or through Zoom. You can try calling, but if I'm not working on campus, I'm not going to be answering my phone or checking my messages. So email is certainly the best way to get a hold of me. So I just want to talk a little bit about Zoom etiquette, just to make sure everyone's on the same page here. Be on time, always good for your classes. Be respectful. So hopefully that goes without saying. Always a good rule in life is be respectful, use appropriate language, talk nicely about others, all those kind of things. Shouldn't need to remind anybody of that. This one here is important. I know you're on Zoom, you're at home, you don't have to be wearing pants, all those kind of things. But I have seen people accidentally turn their camera on, and I don't want this to happen to you where you're accidentally in, let's say, your bathrobe or something less appropriate, or maybe someone in the background at your house is walking by in a bathrobe or underwear or something like that. So dress appropriately, be aware of your surroundings, those kind of things, just in case that kind of thing happens. We don't want anybody to be in that situation. Also with the microphones, just turn your microphone off unless you're going to use it. People have dogs or other pets or people in the background, and we don't want to be cluttering up the noise in the class. If you do wish to speak, ask a question or make a comment, feel free to unmute your microphone, not a big deal. But otherwise, keep it muted. You can also ask questions or put in comments using the chat function, and I'll be checking that periodically and can address any questions that you have with that. And as always with classes, come prepared to learn. So hopefully that's all kind of straightforward stuff. I have another just kind of reminders about COVID protocols, and these things are always evolving, and I'll try to make you aware of anything, any changes when we get on campus. So, make sure you wear your mask and have your campus access card and those kind of things. And like I said, if there's any changes, I'll try to remind you, and as I find out of them myself. So let's talk a little bit about the course. This is a water quality course. So water quality is talking about the many aspects of water. And you probably know water is super important for so many things on the planet. Biological processes, geological processes, all those kind of things. And there's lots of ways we can look at it and describe it, lots of things water is used for. And so we're going to really be getting into a lot of the nitty-gritty around water. And another thing too that when you talk to people, it's something that you don't realize how important water is to everybody. Some people have cabins, they like canoeing. Well, obviously we consume water. Water is such a huge part of our lives. And so these are some things that we're going to kind of get into here in our course. So in terms of learning outcomes, just want to point out some of the key things in the course. we're going to be looking at just some basic water chemistry, physical properties, biology of water, those kind of things. The later part of the course, we're going to be talking a lot about water processing for drinking water and wastewater treatment. We're going to be talking about obviously environmental issues, and we're also going to be producing lab reports and those kind of things. So we'll talk a lot more about the lab reports and the data analysis for that in a few minutes. And we do have one topic on which is about two to three lectures on air quality as well. And that's mostly at the end of the course. And so hopefully you'll find that interesting as well. So make sure you do go to Moodle all the time. You're going to get your notes there. I'll have practice questions for some of the units, those kind of things. This is where you're going to submit your labs. So I'm not going to go through Moodle. I think everyone's familiar with Moodle. So in terms of evaluations, this is the evaluation of the course. We're going to have 4 tests. I don't have dates for the tests. They're roughly every 2 to 3 weeks over the semester. And so each test covers, you know, kind of 2 units, something like that. So they're somewhat regularly. I'm not calling them quizzes. They're longer than quizzes. These tests are like 20, 25 minutes. They're not midterms because a midterm is a lot longer. So tests, I think, is appropriate. I think most people kind of like this format. It's not as heavy weighted as, say, a midterm, and not as meaningless as, say, a quiz where you're getting nickel and dime to death. They're each worth about 10% each. Lab is 35%, the final exam is 25%. So these are the topics. Like I said, I don't know why that and is in bold, but we're going to be talking about all sorts of different aspects about water quality, water processing, those kind of things, and finish off on air quality. So this is the lab schedule, and labs start January 20th. So where are we now? We're January 5th today. And so that is not next week, but the week after. So we have a little bit of time before we get started on the labs. But one thing I do want to point out with the labs is that they happen in different locations, depending on the equipment we're using. Sometimes we're in the chemistry lab, sometimes we're in the environmental lab, and sometimes we're in a computer lab. And I'll talk about the computer lab exercises a little bit later on in the course in terms of how that's going to work. And we're hoping to have 2 field trips at the end of the semester. With COVID, that hasn't happened in the last 2 years. Kind of depends on what the regional municipality decides, whether they're taking visitors or not. And so at the moment, it's kind of like a big question mark. I'm probably not going to reach out to them until maybe around the beginning of March. So we'll know a lot more around then. So hopefully we get to do it, or at least one of those field trips. They're both relatively good field trips. And it's really, the nice thing about these field trips is you end up going and seeing a lot of the processes that we talked about over the semester. And so I kind of have them penciled in there. I have an alternate date for field trips in case those other 2 dates don't work. Sometimes they get canceled last minute and have to reschedule. So there's always leave an alternate date in there for the field trips. So a little bit more about the labs. The labs, there are short reports and one large report. Take a look at the lab manual, and you can see there's a bit more information about that. And I'll be talking about lab reports kind of as we go along. They have usually there's a few questions, there's some data analysis, some discussion questions, those kind of things, and hopefully pretty similar to what you've seen before. So like I said, I'll talk a lot more about the labs as we get closer to, and kind of each week as we go through the labs, I'll talk a little bit about what is expected for each of these, and hoping for good things from your lab reports this semester. We have one new lab this year that is related to air quality. So lab 2A is a bit of an air quality lab. And so we get to be the guinea pigs, the first group to actually do this particular exercise. So I'm really looking forward to that. So just reminders about the things you need for the labs. You need the training. I'm not even asking people for your WIMA certificates since I know everyone was here last semester. I'm assuming you have it. Make sure you have your lab coats. Lab goggles are required in the chemistry lab. So do make sure you have lab goggles with you. Make sure you have a permanent marker, so Sharpie or something like that to label things. and of course the current edition of the lab manual. I haven't actually been to the bookstore this week, but I think I was told it was already there. So hopefully it is, and you can pick that up. And but either way, we don't need it today. Need it for January 20th. So one other quick reminder about the labs. Been having some issues with this. People love those short socks. You do need to have your ankles covered. So this is just a reminder because I've just been having this issue. So find some socks, proper socks, or pants that go all the way down, and it won't be an issue. So what about how to be a success in this class? I went to a workshop that talked about successful students a few years ago, and they're talking about, you know, here's the list of things that successful students have, apparently. I kind of was looking at this list and highlighted a few things there. So you can see critical thinking, problem solving. We're going to be doing a little bit of problem solving, and you know, a good chunk, maybe a third of your testing experience is going to be solving problems and calculations. Most of them are not too difficult. They're usually relatively straightforward, and you're going to get a lot of practice doing them. A little bit of active listening and studying and things like that. Most people don't find this course very difficult. Just to give you an idea, I cannot remember the last time someone has failed this course. It's been years. So it's not usually a big, not usually too difficult. Test preparation, there we go. Another thing is, I just ask everybody always to consider how they're using their technology in classes. Mainly, I mean, if you want to distract yourself, that's one thing, but rather that you're not distracting others. Always nice to come to class to learn and ask questions and engage rather than distracting yourself. So just a little reminder on that. So some last thoughts. I think I kind of already mentioned this, is that water quality it really is a big merging of all sorts of other disciplines, including chemistry and physics and biology and all sorts of things kind of in one course. And I think you're going to enjoy this course. Most people do, or at least they find something they like in the course. The labs are fun. The labs are very hands-on and very practical, and most people really enjoy the labs in this course, and they're kind of designed that way in terms of just to give you a little bit of experience with all sorts of different things and different types of instruments. And most people know at least a little bit about water, so we all use it, so we all have something that we like about it. Little cartoon for you. If you think about all the water molecules on the planet, and they've been sitting around and doing all sorts of things, it's just kind of like mind-blowing to think that, you know, the water in these rivers may have been water that a Tyrannosaurus Rex was drinking a long time ago, and those kind of things. But anyway, I'll have a few cartoons I'll share with you, some funny, some deep and meaningful, and all those kind of things. So just a reminder to download the course outline and always take a look. There's probably details in there that are missing, or there might be things in there that are relevant to you or important to you. I know they're not the most interesting things to read, but it is a document that's important to hold on to for your education. So I'm going to get right into topic one. Topic one is just a little bit of an introduction about water properties and talking about a few different aspects of water. I've got some interesting tidbits and some couple of little cute videos to show you and those kind of things. And then next day we'll get into topic two. So each of my, there is no textbook for this course, by the way. I used to have a textbook, and it just, so many things about it drove me nuts. Like, for example, the textbook would talk about bacteria being plants, for example. I think the textbook was written by an engineer, and he just had so much chemistry and biology wrong. It was just a piece of garbage, and I couldn't find anything that was really very appropriate. So what I have is a lot of web-based references for you folks, and I'll be providing them with the PowerPoints. And I'm not going to necessarily show you them all the time, but you can always do some of the digging when you need it. And other references I might be posting on Moodle for you. There is a document I'll be posting next week called Facts About Water in Alberta. And that one there I consider required reading. So I'll talk about that a little bit more next day. So first of all, just a tiny bit of chemistry for you. There's the water molecule. Anyone remember what geometry we would call this? Remember your chemistry words? Any takers? Somebody's saying bent. Yeah. So technically that's bent. You may remember there's the trigonal, pyramidal, and the, those kind of things. This is bent, right? So that's actually, I'll show you another picture in a minute here. So this says what kind of bonding is present. So there's actually two kinds of bonding present here. Anyone know what they are? There's bonding between the oxygen and hydrogen, and there's actually bonding between the different water molecules. Does anyone know what that kind of bonding would be called?
Single bond?
So I see somebody said hydrogen bond. That is one of the types of bonding. And what about between here, between the oxygen and hydrogen? That would be covalent, right? So I'll show you a little bit of a better picture here. So there's water, and the oxygen and hydrogen are bonded by covalent bonds. They're actually polar covalent bonds. And that's where you have that electron sharing, just kind of the basic chemistry there. But here's the thing, they're polar bonds. And so what you end up with is the hydrogen there is partially positive. So this little thing is a lowercase Greek delta, and it means partial charge or slightly. I think it looks a little bit like an S, so I think of it as slightly positive. And the oxygen is being slightly negative. And so they have a bit of a special type of dipole-dipole interaction, which is called a hydrogen bond. You can see it's involving a polarized hydrogen here and an electronegative atom. And so hydrogen bonds are often represented in textbooks as these dashed or wedged, or these little dashed or dotted lines. And you can see those there. If you take organic chemistry, you talk about hydrogen bonds in a lot more detail. But they're basically a very, very strong dipole-dipole interaction. They're about, if I remember correctly, maybe a quarter of the strength of an ionic bond. And if you think about something like water, where you have, tons and tons of molecules, they can actually be quite cumulative. And it's hydrogen bonds that give water a lot of its unique properties. So we're going to be talking about some water properties here and kind of just go through and defining a few things. And that's kind of today's lecture. So one property that water has is cohesive and adhesive behaviors. So they kind of mean similar things. They kind of mean molecules sticking to one another. So cohesion, right, means you got the same thing, right? So water sticking to water. Adhesion is water sticking to other things. So I'll show you guys a couple of examples. So here's one example actually that has both. So some people wonder, how does the water get from the roots and it goes up the plant? And if you think about some of these trees are just tall and massive, there's no pumps, there's no pressurized systems in there. It's actually all hydrogen bonding. And it's that hydrogen bonding of the water sticking to water, so that's cohesion. You can see that shown right here. And we also have the water sticking to the vascular tissues in the plant, and also hydrogen bonding. And eventually, actually, some of it's even lost out the leaves due to transpiration. I think I've got a little animation here kind of showing that type of thing. And it's basically, like I said, just water sticking to things and itself. And so water is very good at that. Water is very good at sticking to itself. And that's why we get water droplets. Most liquids form droplets, but water droplets can be actually quite large compared to a lot of other liquids. And so you see that water dripping out of your tap forms a kind of a ball shape. And there's a nice picture of water beating on a leaf. And this kind of thing is called actually surface tension, which means that the water mass is trying to shrink to the minimum surface area possible, which is really a sphere. Surface tension is actually really important for some insects. So here's a water strider, and these animals are actually more dense than the water, but they can actually walk along the water. I'm going to show you a video here of something else that is just really super fascinating here. Let me just click on that link, and I'll have to share my screen here. Just give me a second. Change my screen share. And this is actually a lizard here. And if you take a look, it has a unique name. It's called, some people call it the Jesus Christ lizard. And I'll explain as to why it has that name here in a second. And I'll actually let the National Geographic person do a lot of the talking.
Some young Costa Rican basilisk lizards are looking for food. Basilisks have been nicknamed the Jesus Christ lizard. Why? This adult male, probably the father of the young lizards, can't tell us. Nor can this female, exclusive property of the territorial male. It has nothing to do with the feeding habits of the basilisk, which consists primarily of insects and berries. This predatory reptile will help reveal the secret as it stalks the young basilisk. The basilisk is called the Jesus Christ lizard because it can walk, well, really run on water. It bicycles its hind legs, and the tail becomes a counterweight. We can't know what the snake is thinking. Did it really want to eat the lizard, or did it just want to show?
Anyway, I thought you might like that video. I think that's just, every time I see it, it's just absolutely fascinating to see that lizard do that. A basilisk lizard, I think they're found in Central America, so places like Costa Rica and whatnot. But they're using that surface tension. So kind of a cool property of water. And like I said, cohesive adhesive behaviors just means water sticking to itself or other things. Another unique thing about water is it stabilizes temperatures. So if you take a look at the physical properties of water in terms of something like specific heat, specific heat is, you can see the definition there. It's basically the amount of energy absorbed by a substance, technically programmed to raise it 1 degree Celsius. So water, compared to a lot of other liquids, actually has a pretty high specific heat, which is why it's actually a really good coolant and used in a lot of processes. Also, it's cheap, so it's another reason why it's a good coolant. I'll show you some ramifications of this. If you take a look at this, it's showing a map of the west coast of the United States, and you know a little bit about the geography of that particular region. If you go a little bit inland, basically you get some really hot places that are deserts, but the closer you get to the ocean, the average temperature, unfortunately everything's here in Fahrenheit, so I don't even know what these numbers mean, but they're lower, right? And this is because the ocean itself acts as a bit of a heat sink. It's cooling these coastal areas, and so you get, you know, beautiful California, which just has wonderful weather, and it's not a desert there. Another application is humans. This is why we sweat. We sweat to cool off our body. And so, you know, this is usually a good thing. Sometimes it's a little embarrassing if you've got the problem this guy has, but it does work. Another property about water is it expands when frozen. I'll show you some images here of some of the chemistry here, but first question is, what is density? Does anyone know what density is? So density is a little d, I think. It's basically mass per volume. So that's all it is. So usually it's grams per mils or grams per liter or something like that. And here's the other question: how does water structure change as the temperature changes? And so if you take a look at this, like I have a chart I'll show you here in a moment. But if you think about the three different states of water, we have water vapor, which is very, very low density kind of substance. You have these molecules and they're barely interact. They're separated from one another. In liquid form, the water molecules are actually quite close. They're slipping around. They're not static. But as water freezes, it starts to solidify and crystallize its hydrogen bonds, and actually forms this kind of you can see it's a hexagonal type of matrix, and it actually pushes the water molecules a little bit further apart. So the consequence is that water, when it's frozen, actually floats. And this is not the same with most substances. With most substances, as they get colder, they get more dense. So having a substance where the solid form actually floats is kind of unique and actually hugely important biologically. You can see here's the chart, and you can see here that water is actually most dense right here at about 4 degrees Celsius. And as it's frozen, it's less dense. And so, like I said, it floats, which is really kind of cool, that ice floats. There's another image of the structure with all the hexagons and all the hydrogen bonds forming. You can see all those dotted lines are representing hydrogen bonds. So this, like I said, is really important biologically, because this is the reason why fish and other aquatic organisms can actually survive in the winter. If you think about it, if a lake were to freeze from the bottom up, everything would get frozen solid and it would kill all the animals in the water. So really important if you're a fish. I have a little cute animation for you. It says here, this is the reason why penguins have so much fun. I don't know if anyone's seen this one. This is a really cute little video. Ready? Wait for it, wait for it. Oh, I laugh every time. We'll play it for you again. Pretty sure this is somebody, not a real penguins, but I'm not entirely sure. There's another version. Here's the other version. Sorry, I just find these videos hilarious, so I figured I'd share them with you. Okay, and next property, water is a powerful solvent. So, you know, in nature, and in actually most places, water is often never, like, it's really hard to have a pure water. It's almost always contaminated or polluted or has something in it, because water itself is actually a really marvelous solvent. And particularly its salt will dissolve ionic and polar things very readily. You can actually, you know, test it out with some salt. Get a glass of water and see how much salt you can dissolve in that water. It's actually quite a bit. Same thing with just simple things like table sugar. This is a diagram showing sodium chloride being dissolved in water. And we're going to talk a lot about, in topic 3, we're going to talk a whole bunch about all sorts of different things that can get dissolved in water and how we can kind of analyze and talk about them and think about them. So we'll come back to this a little bit later. Water also has acid-base properties. So water itself can be an acid or a base. If you think about these definitions of acids and bases, you probably talked about them in grade 11, grade 12 chemistry. I'm not sure if chemistry 101, if you talk about acids and bases too much, I can't remember which is in which course. But this is usually the general definitions of acids and bases. Acids donate hydrogen ions, bases accept hydrogen ions. And we're going to talk a lot about pH. In fact, we're going to get right into pH in lab 1. And so this will be one of the formulas that will be important to know for this course. And so we'll come back to that in topic 3 and also in lab 1. One thing you may know about the pH scale is it's a logarithmic scale. So if you take a look at that previous slide, you can see this mention here that, for example, pH 6 is 10 times more acidic than pH 7. So if you look at this pH scale, as we go in this direction here, we become more acidic. As we go in this direction here, we become more basic. And you can see there's a whole bunch of different substances and drinks and those kind of things, and just kind of shows you where they're found roughly on the pH scale. So 7 is considered neutral. Human blood is slightly alkaline, maybe about a 7.4 to a 7.6. Seawater is about an 8. A lot of cleaning detergents and things like that tend to be alkaline, and a lot of juices and drinks, Coca-Cola, orange juice, those kind of things. A lot of foods in general tend to be a little bit acidic, or in the cases of things like Coca-Cola, are actually quite acidic. One more thing, viscosity. So this is something else we're going to be talking about a little bit. I think this is lab 5. We're going to talk about, we're going to kind of analyze what's going on here. And this is a little bit more important when you're thinking about things such as fluid dynamics. By fluid dynamics, I mean the movement of water in things like tubes and pumps and things like that. And one of the consequences of water is it actually has a little bit of friction to it when it's flowing through things. So that means if you have a really skinny pipe, you're going to see a lot more friction for that amount of water, because there's more pipe that water is going to see. So, well, like I said, more on this kind of in lab 5. This particular unit is really just an introduction to some of the properties of water before we get into some really big specifics. Okay, so test yourself. This should be super easy. Which property of water gives it its unique properties? So if there's any one thing to remember, is this here. Water can form hydrogen bonds, and it is really a big part of what allows water to do what it does. Like I said, a lot of these properties we talked about, being a good solvent, the adhesive and cohesive properties, it would not be so effective if it was not for those hydrogen bonds. So there are other water properties. We could certainly talk about rainbows and all sorts of other things. Some of the things we will talk about, we're going to talk about water hardness. That's due to dissolved bivalent cations, for example. We're going to talk a little bit about conductivity. Dissolved oxygen is important if you're an organism that needs oxygen. Fish love dissolved oxygen. So lots of other things that we are going to talk about. And just like I said, this was mostly an introduction to kind of get into talking about water. If you want to watch, I'm not going to play this for you right now. You can do this on your own time. There's a cute little video here on the properties of water from the Amoeba sisters. Actually, if you're looking for a really entertaining kind of biology, sciencey YouTube channel, check out the Amoeba sisters. They're cute, they're fun, they're educational. What more could you ask? So that's it. That's it for today. Topic 1 is done, and course outline is done. We're going to get into things on next week, on next Monday. In the meantime, make sure you have all of your lab equipment, your lab manual, those kind of things, and I'll see everybody on Monday.